we're going to work on the substitution method for our homework that we discussed in class. Now, the substitution method is just that. We're going to substitute, or we're going to replace. What I typically tell students is you're going to substitute one equation into the other equation via a variable, either x or y. So what that means is one of the equations has to be of the form x equals something or y equals something. You have to have this for one of the equations, and whatever it is, you plug that into the other equation. And this is what I'm talking about. The second equation of the first problem here, if we solve for x, we get here, we're going to add y to both sides and solve for x here. Okay? So let's add y to both sides. And we'll get now x equal to y plus 3. This is what I'm referring to. That the second equation has x equal to something. And that something here is a y plus 3. So now here's what we're going to do. My first equation has 2 times x. I'm going to use this x that we just discovered is equal to y plus 3, meaning in the first equation, we're going to replace x. Excuse me. We're going to replace that x with, excuse me, replace this x. Maybe we'll bring this, let's bring this first equation down here. How's that? 2x plus y is 3. We're going to replace the x with y plus 3. Take a look. X is y plus 3 here. So here's my x. It gets replaced with the y plus 3. That's plugging the second equation into the first by the variable x. This is known as a substitution method. So we now have 2 times y plus 3 plus our y equals 3. So let's distribute the 2. 2y plus 6 plus y is 3. And we end up getting, let's put the work up here, 3y plus 6 equals 3. Subtract your 6 from both sides. We get 3y is negative 3. Divide both sides by 3 now. Y is negative 1. So this is how we use the substitution method. We substitute the x equal to y plus 3 from the second equation into the first equation. This is the new x value. And we now have to use back substitution. Now let's kind of be careful with this. Let's use back substitution here to find the other value. Now this is the same back sub you used for the addition method homework. So we're going to use y equals negative 1 here. Now we can plug negative 1 into any of these equations. It looks like when we write on the top there, it really doesn't like that. So we're going to use y equals negative 1 into any of the equations. I'm going to use y as negative 1 up here. So I get x equals not y plus 3, but x equals negative 1 plus 3. So x is negative 1 plus 3. And then that gives me x is the value positive 2. So the point of intersection is 2 comma negative 1. This is the substitution method. Number 3, x plus y is negative 4. X minus y is positive 4. We're going to do the following. We're going to add y to both sides for the second equation. This gives us x equal to a y plus 4. This is the second equation. It's the new second equation. So x here is y plus 4 in the second equation. X is here in the first equation. We're going to replace that with a y plus 4. We're going to substitute. The first equation is not x anymore, but y plus 4, plus the additional y here, and that'll equal negative 4. So we're going to substitute y plus 4 for the variable x. We can now solve this equation for y. We get 2y plus 4 is negative 4. We subtract 4 from both sides, and your 2y will be negative 8. Divide both sides by 2. Y is negative 4. We're going to now use back sub. Back sub will give us the corresponding x coordinate value. Now I'm going to use my back substitution over here because it's already solved for x. And what that means now is x will be negative 4 plus 4, or x is the value 0. My point of intersection is 0 comma negative 4. And you are done. Number 5. X plus 4y is negative 3. Negative x minus y is positive 3. Let's do the following. Let's solve the first equation for x, meaning x plus 4y is negative 3. Subtract 4y from both sides. You get x equal to negative 4y minus 3. Now that's my first equation here. The second equation still is negative x minus y, and that equals positive 3. So here's what we're going to do. Let's use this. Since x is negative 4y minus 3 in the first equation, we're going to plug in into the second equation. There's my x. We're going to plug in negative 4y minus 3. What happens now is I have negative 4y minus 3. Let's write it down here. Negative 4y minus 3 minus y is positive 3. I replaced my x coordinate with negative 4y minus 3. Negative, or I should say distribute this negative sign, we get 4y plus 3 minus y is 3. Or we should say we get 3y plus 3 is 3. Let's subtract 3 from both sides. We end up with 3y equals 0. Divide by 3 for both sides. We'll get y equals 0. We're going to use back substitution. Y is 0 here. So let's go back. If y is 0, I'm going to plug this into this new first equation because this gives me x equal to negative 4 times 0 minus 3, or simply x is negative 3, because negative 4 times 0 is 0. This portion here is really gone. So x is negative 3. This is what we get when we use back substitution. Our solution is negative 3, 0. Number 7. 3x minus y is negative 2. X plus 2y is negative 3. Let's solve the second equation for x by subtracting 2y from both sides. So my second equation now is, let's write the first. 3x minus y is negative 2. The second equation is x is negative 2y minus 3. Here we go. X is negative 2y minus 3. Replace the x in the first equation with negative 2y minus 3. This gives us 3 times negative 2y minus 3 minus y is negative 2. When we distribute, we get negative 6y minus 9 minus y is negative 2. Negative 10y minus 9 is negative 2. And let's double check here. Of course, we didn't make any arithmetic errors. 3x minus y is negative 2. X plus 2y is negative 3. X here is negative 2y minus 3. Okay. 3 times negative 2y minus 3 minus y is negative 2. Negative 6y minus 9. Okay. We made an arithmetic error right here. Negative 6 and negative 1 is negative 7y. Okay. Add 9. See what we get. Negative 7y is positive 7. Divide both sides by negative 7. And what does y equal? Y is negative 1. I'm going to go plug in a negative 1 here for y. This gives me, by back substitution, x equals negative 2 times negative 1 minus 3. We just plugged in y being negative 1 back up in here. We could plug in negative 1 for any of these equations. It won't matter. I just plugged it into one that would be the easiest. So let's look at the work. Negative 2 times negative 1 will be positive 2. So that x will be positive 2 minus 3, or x is negative 1. We get negative 1. Your y-coordinate is also negative 1. Number 9. X plus 4y is 5. 3x plus y is negative 7. We're going to solve the second equation for y. I'm going to subtract 3x from that second equation. Second equation gives me y equals, well, Let's write this first this way. First equation is x plus 4y is negative 5. My new second equation is y equals negative 3x minus my 7. Y is negative 3x minus 7. Here's the y coordinate value. So I'm going to plug in the second equation into the first by the y coordinate. That gives me x plus 4 times negative 3x minus 7 is 5. We distribute x minus 12x minus 28 is 5. Negative 11x minus 28 is 5. I'm going to add 28 to both sides. Negative 11x will be 33. Divide both sides by negative 11. X gives you the value of negative 3. Now, go back here to the new second equation. When you use back substitution, I'm going to plug back in my x value being negative 3 into that particular equation because it's already solved for x. We discussed this in lecture. So let's write this down. If y is negative 3x minus 7, and we know x is what value? Negative 3. Let's plug this value in. We get y is negative 3 times negative 3 minus 7. Y is positive 9 minus 7, or y is 2. 9 minus 7 is 2. Our solution is negative 3 comma 2. This is the point of intersection. This is number 9. Let's look at 11. (3x plus y) is negative 11. X minus 2y is positive 8. We're going to solve the second equation for x. So my first equation stays unchanged. It's 3x plus y is negative 11. For the second equation, we're going to add 2y to both sides. So we get x equals 2y plus 8. X is 2y plus 8. I'm going to plug in the second equation into the first by the x variable. I'm going to replace x here with 2y plus my 8. I'm going to substitute. I get 3 times that 2y plus 8 now, plus my y is negative 11. I can solve this equation now. Let's just distribute. 6y plus 24 plus y is negative 11. 7y plus 24 is negative 11. I'm going to subtract 24 from both sides. We get 7y is negative 35. Divide both sides by 7. We get y equals negative 5. We're going to use back substitution. We're going to plug back in the y value into this new second equation because it's already solved for x. It's the easiest one to do. So if x is 2y plus 8, let's double check, and y is negative 5, I'm going to plug in y being negative 5. 2 times negative 5 plus my 8. Negative 10 plus 8, or x is negative 2. Negative 2, negative 5 is my intersection. Number 13. 2x plus y is 9. 3x minus 5y is 8. I'm going to solve my first equation for y. So my first equation is 2x plus y is 9. Let's subtract 2x from both sides. The first equation becomes y equals negative 2x plus 9. Now let's write this down here. Y is negative 2x plus 9 for the first equation. 3x minus 5y is 8 for the second equation. So let's check. Y is negative 2x plus 9. That's my first equation. We're going to plug it into the second equation by the variable y. 3x. Let's write this down. 3x minus 5 times negative 2x plus 9. And that's an 8. 3x plus 10x minus 45 is 8. 13x minus 45 is 8. Add 45 to both sides. 13x will be, is that 53? Let's double check we didn't make a mistake. Number 13, 2x plus y is 9. 3x minus 5y is actually 7, not 8. Okay. That makes things a lot nicer. You can divide both sides now by 13. And you get x is, I believe, 4. Now we're going to use back substitution and plug back in my x value into this new first equation, or this new first equation, whatever you want to call it. So I get y is 2x, negative 2x plus 9. And I got x being 4. So this means y is now negative 2 times 4 plus 9. Or y will be negative 8 plus 9. You find y being positive 1. So my x coordinate is 4, 1. There you go. Number 15. X plus 3y is 4. Number 15. 2x minus 5y is 8. We're going to solve the first equation for x. So we have x plus 3y is 4. Subtract 3y from both sides. X is, let's write it this way. Well, you can actually write it as 4 minus 3y if you like. Or negative 3y plus 4. Either way is fine. This is my new first equation. The second equation is 2x minus 5y equals to 8. So let's write it a little bit closer over here. Let's write it this way. 2x minus 5y is 8. X is 4 minus 3y in the first equation. I'm going to plug that in to the second equation. I'm going to plug in the first equation into the second equation by the variable x. We get 2 now times 4 minus 3y. We have to put this in parentheses. Don't forget there's a minus 5y there. And now we get to distribute. 8 minus 6y minus 5y is 8. 8 minus 11y is 8. Subtract 8 from both sides. We get negative 11y is 0. Divide both sides by negative 11. Cancellation, we'll get y is 0. Plug in a 0 here. And we now get x is 4 minus 3 times 0, or x is what? 4. 4, 0. 4, 0 is our solution. Number 17. Two x plus y is negative 5. 4x plus 2y is negative 6. We're going to take the first equation here, and we're going to solve this equation for y. Okay, first equation, solve for y. Subtract 2x from both sides. We get y equal to negative 2x minus 5. That's our first equation. Y is negative 2x minus 5. The second equation is 4x plus 2y is negative 6. Y, negative 2x minus 5. Plug the first equation into the second equation by the variable. 4x plus 2 times negative 2x minus 5 is negative 6. 4x minus 10 is negative 6. Well, we end up with negative 10 is negative 6. Let's double check here. Make sure we did everything correct. This here is a false statement. This means that there is no solution. Okay? My lines are parallel and they never intersect. The solution set is empty. So these are all the things that you'll see here. You'll see in back of the book. Solution set is empty because lines are parallel, they never intersect, therefore there's no intersection point, there's no solution. This happens when you have a false statement because negative 10 simply does not equal to negative 6. Number 19. X plus 3y is negative 9. 2x plus 6y is negative 18. We're going to solve the first equation for x. We're going to do that by subtracting 3y from both sides. I get x is negative 3y minus 9. That's my first equation. The second equation is 2x plus 6y is negative 18. X is negative 3y minus 9. I'm going to plug the first equation into the second equation by the x variable. Get 2 times negative 3y minus 9 plus 6y is negative 18. Negative 6y minus 18 plus 6y is negative 18. Now my y goes away, and I get negative 18 equals negative 18. Notice this. Negative 6y plus 6y, the y variable is canceled. This is actually a true statement. It's a true statement. That means these lines are the same. These are the same lines. Therefore, we say there's infinitely many solutions because it's the same line. You're looking back at the book. Formally, set notation will say this. It's a set of all points x and y such that now pick one of the equations. I'll pick the first one. This is what you see in back of the book because what you're saying is every point on this line is a point of intersection, and that's true because it is the same line. They're on top of each other. This is what we discussed in class. Number 21, 3x minus 2y is negative 4. 3x minus 2y is positive 6. This is interesting. This is number 21. Looks like this is going to be a false statement. Let's try this out. Let's look at the first equation. 3x minus 2y is negative 4. Let's solve for y. I'm going to subtract my 3x from both sides. I get negative 2y is negative 3x minus 4. Divide both sides by negative 2. And I get y is negative 3x over negative 2 minus 4 over negative 2, or y is 3/2 x plus 2. I'm getting a little suspicious here about this one. I know this, we can actually substitute if you wanted. Let's do that. This is my first equation. This is my second equation. We say that we're going to solve for y in the first equation. So I'm going to bring down the second equation. So let's get rid of this circle here. And now let's bring down the second equation. We say, okay, 3x minus 2y is positive 6. Let's do our substitution. Y is 3/2 x plus 2. The second equation, we have that y. You get 3x minus 2 times 3/2 x plus 2, and that's going to equal 6. 3x, let's distribute the 2. Minus 3x minus 4 equals 6. You get negative 4 is 6. This is a false statement. This is false. Negative 4 is 6. That means there's no solution. These lines are parallel. Number 23. X minus 2y is negative 2. 3x minus 6y is negative 6. We're going to solve the first equation for x. X minus 2y is negative 2. I'm going to add the 2y to both sides. X is 2y minus 2. This is in the first equation. So my first equation is x is 2y minus 2. The second is 3x minus 6y is negative 6. X, let's go back. X is 2y minus 2 in the first equation. We're going to plug that into the second equation by the x variable. That means replace this with a 2y minus 2. Here's what we get. 3 times 2y minus 2 minus 6y is negative 6. 6y minus 6 minus 6y is negative 6. We got opposites so that my y value goes away. And negative 6 equals negative 6. This here is a true statement. That means there is infinitely many solutions. You'll see in any algebra book a set of all points x and y such that, now pick an equation. They'll write it this way. That means every point that is on this line is a solution, and that makes sense because these are the same lines. They're on top of each other. This is the end of our homework.